from this channel. Today I'm going to teach you about the types of chemical reaction and chemical equation. So here are some basic definitions you need to know. Atom, it means the smallest part into which an element can be divided. Molecule, the smallest unit into which a substance can be divided without changing its chemical nature. Definition of element, any substance that cannot be decomposed into simpler substance by ordinary chemical processes. Compound, something that consists of two or more elements combined together. So we're going to start with chemical reaction. So what's a chemical reaction? The chemical is a transformation of chemical substance into another chemical substance, which is known as chemical reaction. In a chemical reaction, a new substance is found different in the properties, which is different. It is completely different from the properties from the original substance. So, in a chemical reaction, a chemical change takes place. So, for example, resting of iron, the setting of milk can occur, digestion of food, etc. So, for the second point, let me give you an example. So, the setting of milk into curd. So, does the curd have any properties of milk? Yes or no? Type the answer in the comment. Okay, here are some chemical reactions in everyday life: combustion, rusting, digestion, photosynthesis, batteries, in our TV remote, washing our hands, baking. So only an rearrangement of atoms takes place in a chemical reaction. As the substances which take part in the chemical reactions are called are called reactants. The substances which are produced as a result of a chemical reaction are called products. So here's an example: NH3 plus HCl are the reactants, and NH4Cl is the product. So here's a simple mind map. The types of chemical reactions are synthesis reaction, decomposition reaction, single displacement reaction, and double displacement reaction. So the first we are going to start with the synthesis reaction. It's basically the reaction where two or more molecules react together which forms a new substance. So here's an example: A plus B is AB. So this element and this element, when they join together, when they react together, they form a compound. Here's an example: C plus O2, CO2, carbon dioxide. CaO plus H2O is CaOH2. So here's another example: sodium plus chlorine is NaCHL, which is salt. So decomposition reaction. Decomposition reaction is a reaction in which one reactant breaks from two or more products. So it's basically the opposite or converse of combination reactions, which is also known as synthesis reaction. So here's an example. Here's a compound, which is the reactant AB, and when when the decomposition reaction occurs, it will be divided into A plus B. And here are some examples: Zn plus CO3, and when it's heated, it will divide into ZnO plus CO2. And here's another example: 2Al2, 2Al2O3, and when that is heated, it will divide into 4Al3O2. Single displacement reaction. Single displacement reaction is the reaction in which one of element is substituted for another element in a compound. When the replacement reaction occurs, a new aqueous compound is different pure element, and a different pure element will be generated as products. So C, AB plus C will be AC plus B when the single displacement reaction happens or occurs. So here's an example: F2 plus 2NaBr will be 2NaF plus Br2. So this element and this element gets replaced in the product. So this will be here. So 2NaF, and this will be here, and Br2. So double displacement reaction. In displacement reaction is a reaction in which positive and negative ions of two ionic compounds exchange place to form a new two compounds. So here's AD, AB and CD. So he take it as B compound and D compound. So when the double displacement reaction happens, the displacement will be double. So here you can, as you can see in the products, the A and A and C, A and C, no, sorry. Yeah, here you can see that this B element, B compound and D compound is exchanged, and C compound is exchanged to this element, and A went to this element. You may think in the product that this hasn't changed, but these places have been changed. This D element has come to this place, and this B element comes to this place. So double displacement reaction happens. So here's an example you want to go through. So then now we are into the chemical equation. So we are going to see how to balance a chemical equation, which is H2 plus O2 has 2. I took a very simple chemical equation because it's very easy to understand, as well as it was the one I took good from the internet. So here's I already did the balancing the equation, like H2, this is a subscript, and this is a subscript. So if there's a subscript, the element has no atoms, but all by itself. So H2 2 and O2 2. So that's the atoms in the reactant side, which is 4, and in the product side there's 2 H2, so H2, and oxygen there's only one atom, and when there is no when there is no subscript, it is considered as 1. So 3. So that's the total 2 plus 2 4, and 2 plus 1 3, which is not balanced. So we are going to balance it now. So first we are going to balance O2 atoms. Let me take my pen. Yeah. So here are the reactants, and here's the product. In the reactant side, there's two atoms here, and so 2, and in the product side there's only 1, which is this one. So now we're just gonna multiply the product number, or the lesser number, to get with the number which will make the product number to get as equal as the reactants number. The higher number. So H2 plus O2 to H2O. This will and here whenever balance an element's atom, you have to write in the coefficient or the subscript or the superscript. So O2 will be considered here, and now H2 atoms. You'll be like, why do you have to balance H2 hydrogen atom? Because it's already balanced with you, because we're going to take this equation, not that. So in that equation, it's not balanced. See, in reactant side, 2 atoms, and in product side, 2 atoms. 2 into 2, 4. See. So, as I told you before, we have to put in the coefficient side. 2 into 4. So in the reactant side, we have to put 2 beside the hydrogen element. So 2H2 2H2 plus O2 will be 2H2O. So now we are gonna see how to count numbers of atom in the chemical reaction. So I'm gonna take it. Yeah, 2 into 2, 4. So 4 here. O2, 2. So which would be 6 when you add that. And in the product side, 2 into 2, 4. And 2 from the coefficient, 2. So they both are 6. Now it's balanced. So thank you for watching. Please like and subscribe for more videos.